100 Facts about Radioactivity. Basic Concepts. 1. Radioactivity is the spontaneous emission of radiation from the nucleus of an unstable atom. 2. Radioactive decay is the process by which an unstable atom loses energy by emitting radiation. 3. Radioisotopes are atoms of an element that have different numbers of neutrons. 4. Half-life is the time required for half of a radioactive sample to decay. 5. Ionizing radiation is radiation that can remove electrons from atoms, creating ions. 6. Non-ionizing radiation does not have enough energy to remove electrons from atoms. Types of radiation. 7. Alpha particles are made up of 2 protons and 2 neutrons. 8. Beta particles are electrons or positrons emitted from the nucleus. 9. Gamma rays are high-energy electromagnetic waves. 10. X-rays are similar to gamma rays but are produced by machines. 11. Neutrons are subatomic particles that have no charge. Sources of radiation. 12. Natural sources include cosmic rays, radon gas, and radioactive elements in the Earth's crust. 13. Man-made sources include nuclear power plants, medical imaging, and industrial applications. 14. Radon is a radioactive gas that can accumulate in homes and buildings. 15. Cosmic rays are high-energy particles from outer space. 16. Potassium-40 is a naturally occurring radioactive isotope found in bananas and other foods. Effects of radiation. 17. Radiation sickness can occur after exposure to high levels of radiation. 18. Cancer can be caused by exposure to ionizing radiation over a long period of time. 19. Genetic mutations can be caused by radiation, leading to birth defects. 20. Low levels of radiation may have no noticeable effect on health. 21. The biological effects of radiation depend on the type, dose, and duration of exposure. Applications of radioactivity. 22. Medical imaging uses radioactive isotopes to diagnose diseases. 23. Radiation therapy uses high-energy radiation to treat cancer. 24. Nuclear power generates electricity using nuclear fission. 25. Industrial applications include sterilization of medical equipment and food preservation. 26. Archaeological dating uses radioactive isotopes to determine the age of objects. 27. Smoke detectors use radioactive materials to detect smoke. Safety and regulation. 28. Radiation protection involves measures to limit exposure to radiation. 29. Radiation shielding uses materials to absorb radiation. 30. Radiation dosimetry measures the amount of radiation a person is exposed to. 31. Nuclear regulatory agencies oversee the use of radioactive materials. 32. International Atomic Energy Agency, IAEA, promotes the peaceful use of nuclear energy and ensures nuclear safety. History of radioactivity. 33. Henry Becquerel discovered radioactivity in 1896. 34. Marie Curie and Pierre Curie were pioneers in the study of radioactivity. 35. Ernest Rutherford identified alpha, beta, and gamma rays. 36. Nuclear weapons were developed during World War II. 37. The Chernobyl disaster in 1986 was a major nuclear accident. 38. The Fukushima Daiichi nuclear disaster in 2011 was another major nuclear accident. Miscellaneous facts. 39. Radioactive materials can be found in nature and can be produced artificially. 40. Radioactivity is measured in units such as becquerels, BQ, and curies, C. 41. The half-life of radioactive isotopes varies widely. 42. Some radioactive materials have very long half-lives and can remain hazardous for thousands of years. 43. Radiation can be harmful but can also be used for beneficial purposes. 44. The risks and benefits of using radioactive materials must be carefully weighed. 45. Radioactivity is a natural phenomenon that has been present on Earth for billions of years. 46. The term, radioactive, was coined by Marie Curie. 47. Radioactive materials can be found in a variety of industries, including medicine, agriculture, and manufacturing. 48. The study of radioactivity has led to many important scientific discoveries. 49. Radioactivity is a complex topic that requires careful consideration. 50. Radiation exposure can be minimized by following safety procedures. Please note that this 51 to 100 facts about radioactivity. More on types of radiation. 51. Ionizing radiation can damage DNA, leading to cancer and other health problems. 52. Non-ionizing radiation includes radio waves, microwaves, and visible light. 53. Alpha particles are relatively heavy and have a short range in matter. 54. Beta particles are lighter than alpha particles and have a longer range. 55. Gamma rays are highly penetrating and can travel long distances through matter. More on sources of radiation. 56. Medical imaging uses radioactive isotopes such as iodine-131 and technetium-99 meters. 57. Nuclear weapons use nuclear fission to release a massive amount of energy. 58. Nuclear reactors use nuclear fission to generate electricity. 59. Radioactive waste is produced as a byproduct of nuclear activities. 60. Natural radioactive materials can be found in soil, water, and air. More on effects of radiation. 61. Radiation exposure can cause acute radiation syndrome, ARS, at high doses. 62. The effects of radiation can vary depending on the individual's sensitivity. 63. Radiation can damage cells and tissues in the body. 64. The risk of cancer from radiation exposure increases with the dose and the duration of exposure. 65. Radiation can also affect the immune system and increase the risk of infections. More on applications of radioactivity. 66. Food irradiation uses radiation to kill harmful bacteria and parasites. 67. Radioactive traces are used to study the movement of substances in the body. 68. Radioactive dating is used to determine the age of geological samples. 69. Nuclear medicine uses radioactive isotopes to diagnose and treat diseases. 70. Radioactive materials are used in the production of various products, such as plastics and electronics. More on safety and regulation. 71. Radiation protection involves the use of shielding, distance, and time to limit exposure. 72. Radiation dosimeters are used to measure the amount of radiation a person is exposed to. 73. Nuclear power plants have multiple safety features to prevent accidents. 74. Nuclear waste is stored in secure facilities to prevent its release into the environment. 75. International regulations govern the use of radioactive materials. More on history of radioactivity. 76. Marie Curie was the first woman to win a Nobel Prize and the only person to win Nobel Prizes in 2 different scientific fields. 77. The Manhattan Project was a secret research and development undertaking that produced the first atomic bomb. 78. The nuclear arms race led to the development of a vast arsenal of nuclear weapons. 79. The Cold War saw a decrease in nuclear testing due to international agreements. 80. The Fukushima Daiichi nuclear disaster highlighted the need for improved nuclear safety. Miscellaneous facts. 81. Radioactivity is a natural process that has been occurring on Earth for billions of years. 82. The half-life of radioactive isotopes varies widely, from seconds to billions of years. 83. Radiation can be detected using various instruments, such as Geiger counters and scintillation detectors. 84. Radioactive materials can be found in a variety of industries, including medicine, agriculture, and manufacturing. 85. The study of radioactivity has led to many important scientific discoveries. 86. Radioactivity is a complex topic that requires careful consideration. 87. Radiation exposure can be minimized by following safety procedures. 88. Radioactive materials can be harmful if not handled properly. 89. The risks and benefits of using radioactive materials must be carefully weighed. 90. Radioactivity is a natural phenomenon that is essential for understanding the universe. 91. The term, radioactive, was coined by Marie Curie. 92. Radioactive materials can be found in a variety of products, such as smoke detectors and glow-in-the-dark watches. 93. The study of radioactivity has led to the development of new medical treatments. 94. Radioactivity is a subject that requires specialized knowledge and training. 95. Radiation exposure can be measured using various units, such as becquerels, BQ, and sieverts, SV. 96. Radioactive materials can be stored in various ways, depending on their type and activity level. 97. The use of radioactive materials is regulated by various government agencies. 98. Radioactivity is a topic that is constantly evolving as new discoveries are made. 99. The study of radioactivity has contributed to our understanding of the universe and its origins. 100. Radioactivity is a complex and fascinating subject that continues to be studied by scientists around the world.